So today I wanted to go over another of my pre-calculus extra credit with you guys. And this time, two people got it right. Let's have a look. I gave them this triangle with all three sides. And I also gave them an angle on purpose right here. And the question is, what's the measure of angle A right there? By the way, I will have to tell you, I gave them this extra credit question before I taught them law of cosines. Yeah. Anyways though, let's have a look. Here's A, and if you go across it, hey, we have the side, right? And we can label that as little a. And this is the given angle. If you go away from it, then you see we have the side as well. We can call this capital B and this lowercase b. And we can just use law of sines because we have the angle side. Yeah? So, sine A, which we don't know yet, over little a, 11.44, that will be equal to sine B, which is 38.73 degrees, over that, 5.58. Now, to get A, we can just multiply this to both sides and then take the inverse sine to both sides. So, A will be inverse sine of 11.44 times sine of 38.73 degrees over 8.58. And now we can just use a calculator, and when you do that, you will see A is approximately 56.5 degrees. And of course, make sure your calculator is in the degree mode. So that's it, right? What's so hard about this? Well, no, this is not the correct answer. And most of the people make the mistake. They just box this and move on. Why though? Well, go back to the picture. Have a look at the picture of measure of angle A. That is bigger than 90 degrees. It cannot be 56.5. And of course, we can argue that more mathematically. If you square 11.44, you will see that it's going to be bigger than 4.2 squared plus 8.58 squared. So you can say this angle has to be more than 90 degrees. But I gave them a picture, so that's even better, right? You can trust a picture. I try to make it as accurate as possible. So the two people who caught this is that, 56.5 it's not going to be the answer. So instead, what it is, they're going to find this angle first. Remember, when you use law of sines, if you know that the angle is acute, you have no worries. So we can say this right here is angle C. We don't know, but we can find it. We can do this and that, and then this and that. Find out what C first, yeah? And then just subtract it from 180. So if you do that, you will use sine C over, this will be little c, which is 4.2, and that will be equal to sine of 38.73 degrees over that, 8.58. So C will just be equal to, take the inverse sine and then multiply this to here. Here we have the sine of 38.73 degrees over 8.58. And then from here we can just take A and make it 180 degrees minus B and then minus C. And then use your calculator and you will get approximately 123.4 degrees. And you can see that this right here does make a lot more sense. And this is it. Now the question is that, how come this right here didn't work though? Well, the answer is, unfortunately, when you use the inverse sine function, it can only give you the output from negative 90 degrees to positive 90 degrees. So this is all about the domain and also the range for the inverse sine function. And let me just give you guys a quick review for this. So if you have the inverse sine function, the domain is that you can enter anything from negative 1 to 1 inclusively, meaning including the endpoints. And the range, meaning the output that you can possibly get, is from negative pi over 2 to positive pi over 2, which this is negative 90 degrees and this is positive 90 degrees. So if the answer, the angle right here, is more than 90 degrees, then you will have to think about it in order to use that to help us. So how can I use this answer to really help me with angle A though, without doing this? Well, the deal is that all you have to do is take 180 and then minus that. And if you work that out, you will get 123.5 degrees. And this is also an acceptable answer. It's just because of the rounding for the sides and also the angles. That's why the last digit right here, it's a little bit off, but it's okay, alright? And I'll talk more about how to solve sine, cosine, tangent equations from 0 to maybe 360 degrees in a later video. But for now, how can we use law of cosines in this case? So let's have a look. So there are 3 versions of law of cosines, but technically you just need to remember one. It's all about the setup. When you have cosine A, this right here is equal to the sum of its adjacent sides squared. So we have b squared plus c squared, and then minus the opposite side squared, which is just a squared. And then divided by 2 times its adjacent side, which is bc. And then of course you can just take the inverse cosine on both sides, and let me just write this down. A will be inverse cosine. In order to use this formula, all 3 sides has to be given, so that's why I gave them as well. B squared is this, so that's 8.58 squared, and then plus c squared is 4.2 squared, and then minus a, which is 11.44 squared, and then all over 2 times b, which is 8.58, c is 4.2. And now, if you use a calculator, you'll get the answer, approximately 123.3 degrees. And again, it's just because of the rounding from the question itself. That's why the last digit is a little bit off, but it's okay. This is totally an acceptable answer, assuming that you have provided all the steps. So now, when you use law of cosine, have a look. The answer is just immediate. Here's the beauty of it. Because when you use law of cosines, when you take the inverse, here's the deal. Domain and also the range. For the domain, it's again -1 to 1, just like the inverse sine. But for the range, it goes from 0 to pi. And that is 0 degrees to 180 degrees. So, when you use law of cosines, you will have no worries. Especially, you're just trying to solve a triangle question. Because all the angles in a triangle, it has to be between 0 and 180 degrees. But earlier, for law of sines, if the angle is more than 90 degrees, then you will have to do the 180 minus the inverse sine answer, just like what we did earlier.